Do you want to know how to build your robot? Don't know where to start or what you'll need? Then you're in the right place. And I can't wait to show you this, how to give your robot a face, give it some emotion. This is just so much fun. So a perfect thing for the sort of Christmas time. What do you think about the snow effect as well? It was a little downloadable pack that I added to our live stream. I'll turn it off for now though. So my name is Kevin. Come with me as we learn how to build robots, bring them to life with code, and have a whole load of fun along the way. So in this session, we'll be looking at the 8x8 matrix display and adding that to our robot. This is a sort of an official module that Kevin Thomas released just over a month ago. And it's really, really easy and quite cheap as well. So if I just head over to the overhead shot here, so you can see that's the display itself. It's, I've got one from Key Studio. Other providers are available. I think you get from Adafruit as well. And it's just got the 4 connectors on it. And there's a couple of 3D printed parts as well that we need, but we'll get to that in a minute. And I've got 2 robots here, and there's a third one just waiting to have it added to him. So let me get over to our keynote. Let me hit the right button there, and let me, you don't want to see my show notes. There we go. Right, so this is a basic skill level. Don't need very complicated electronics, programming or engineering skills for this one. It's really straightforward. So let's get to it. So today, yep, we're going to be grabbing the Adafruit LED backpack library, which is something we can add to the Arduino IDE very easily. I'll show you how to do that. We'll be downloading the LED Matrix STL files from Thingiverse. They're the 3D printable files that we need. I've already printed out the parts, so we can cover that off quite briefly, but if you've built a SMARS already, this is quite easy to do. Then we will assemble the parts, so I'll show you how to do that. It's very, very straightforward to do this. We're going to write some code, and we could give our robot a smile and maybe a bit of a wink as well. So you can see on the little animation there that I've got on the robots that I have just on the panel. What do you call it, the pegboard next to me. I keep them all lined up there when I'm not using them, just out the way. So that's what that's all about there. Okay, so 3D printable parts. As you can see in the nice little animation there from Fusion 360, it just basically encompasses the module. So what we'll do, we'll just have a look at that here. Let's actually have a go at assembling this. So there's the module itself. We have the front, I call it the front part, I think it's LED Matrix 1, I think that's called. And literally it's quite a tight fit, but intentionally so. And this is just going to push into there, so just like so. And the only bit that's complicated in this build is this little piece here, which is the connector. I don't know if you can see that. Maybe I'll just put up onto the this screen here. Maybe this can zoom in a bit better for you to see. So you can see there's a little connector, and this pushes through. It's actually 2 parts. And you just got to squeeze these 2 parts together to push it through. Now, depending what kind of PLA you use, you may find this is tricky, or you might find it's fine. So previously, I've made one of these. I made it in the black PLA, which is on this one, and this one actually snapped because the PLA wasn't very flexible. It was very rigid. I don't know if it was too dry or something like that, but essentially when I pushed them together, it just snapped. This version, it's fine. It just seems to work just as we expect it to. So so then what we do, we just, after we push that piece through there, we just line these pieces up, and we just give these a bit of a push into here as well. So let me just do that. So I've not actually assembled this particular one before, so it's probably very tight fit to begin with. There we go, that's one side done, and then we just need to give it a bit of a shove on the other side as well. There we go. So it's quite a tight fit, like I said. Once that's in, that's not coming out again. So if I was not doing this live, I would basically just wheedle that piece in there. Let's see if I can do that with this screwdriver I've got handy. And if not, I'll just carry on and pretend that it worked fine. Here's 2 I prepared earlier. So then the other piece that we need is this, which is from the modular SMARS robot. So just the regular SMARS STL file pack that you can download. For some reason this isn't included in the STL files that come with these. And then all you do there is just, again, push this piece into place. Let's just see if I can do this. It's quite a tricky, see there, you've just got to give it a shove and then it's on. And the idea is it's quite a nice locking piece there, so you can have it in whichever position you wish. So this is going to go on the front here. Instead, we're going to take off this module here, which was our Echo, what do we call it, the rangefinder piece, and we need some different DuPont wires, which I actually haven't got to hand, but we're going to wire this up very simply. There's 4 wires on the side there, and we're going to have a look and see what they are in a second. So this is how we assemble it. It's pretty straightforward. You can see not too difficult to do. There is a 4th piece for this, which is a black piece of acrylic. Now, so Kevin Thomas's design, he says you can either 3D print this piece out yourself as a transparent piece if you have transparent PLA, or you can just get a black piece of transparent acrylic and cut that out. He cuts it out with a laser printer. Not what you call it, a laser cutter. I don't have one of those, so I've just left this out, and to be honest, it looks and works fine, so I see that as a kind of an add-on if you need it to, but not totally essential there. So Lament is saying cool. Metis Reductor saying cool. Yep, I think it's a pretty cool add-on, and it really does, it makes the SMARS come to life. We do lose our distance sensor. We could potentially put that on the back of our SMARS. I have thought about maybe, you know, just putting that back on the back. It's the overhead, just putting that on there, but he'd have to go backwards then to do his range finding, but there might be a way around that in the future. I've got some ideas about that. The idea being, let me just see if I've got this to hand as well, you can buy little camera modules. I did have one in here actually. That are very small. They're not the official camera module. Again, I wish I'd have thought about this before I went. There we go. So this is not the official camera module. Let me just get this out and show you how small this is. This is a Raspberry Pi camera, but it's absolutely tiny, as you can see. So that just slots into the Raspberry Pi 0. And it means that we can have very, very small camera. It's not taking up very much room at all. I was wondering, would it be possible to create our own 3D printable module, have this as a Raspberry Pi 0, and have something like this, where the camera module is actually embedded in part of the face, so as well as it having a face, it can see. And we could use the tech that we built on previous weeks, where we looked at face recognition, object detection. Maybe we could build that out on a SMARS 0. I've not built a SMARS 0 yet, but I am working on it at the moment, so that's another show, I think. So they're the 4 parts that we need. Pretty simple to put together. I've made a little note there that just says this part is from the SMARS Modular Robot STL pack. So if you go on Thingiverse or smarsfan.com, you can find that. I think it's just called the IR connector part, something like that. Okay, so let's go to the next slide, which is the Adafruit software library. So Adafruit have done all the hard work. They've figured out how to make this driver work. All we need to do is just write 4 lines of code to display things on it. So really, really simple. And the way that we bring this in, if I just bring up, this is the Arduino IDE. I might need to go full screen actually. Let me just do that, and I just need to zoom out. So let me just figure out how to do that. There we go. Just zoom out, because we want it to be full screen. So if I just, oh there we go, the screen was locked. I just zoom out like so. If I go to the top of the screen, where we have the Arduino sketch menu, and then we have the include library and then manage library. There we go. And in manage library, we can see all the libraries that we have installed, and we can just search on all of them. So once that's loaded, if we just type in LED backpack, oops, in there, all we need to do is just click on the install button. That's it. That will take care of business for us. That's the software library that's going to make this thing work. So I've just got some code there in a minute that we're going to be looking at, but we're not quite there yet with that. So let's just go back to Keynote. So that's how we install the library. Really, really simple. So next, the actual 8x8 matrix display itself. So you can search for this online as a HT16K33. No idea what those numbers and letters mean, but that's the thing that it is. You can buy the matrix without any board on it, but you would have to figure out your own drivers for that. So I buy it as an entire module. You can buy them in a 3-pack for about $12, something like that. Excuse me. So they're quite cheap to buy. They only have 4 pins on them, so as the screen, 4 pins. So we have the voltage, we have the ground, and we have clock, and we have data. So very simple to figure out how this is going to work. So what we do with that is we connect them to our Arduino. So just like so, I can show you one that we've got built already. I just go over to the overhead for a second. You can see that's pretty much the wires there. So brown and red, let's get this right into the camera so you can see. So brown and red is ground and voltage, and orange and yellow is data and clock. I think the data will be the orange one. That's the convention I always use when I wire these things up. So the clock and the data is going into 4 and 5 pin, and the voltage is just going into here, which is I think I've got it on 5 volts, and just to the ground as well. You just ignore the Bluetooth module I've got there. That's for something else I've got. I'll show you that in a bit. Okay, so let's go back over to our keynote. So very simple for us to wire up. Don't think there's anything else we need to say on that one. Pretty straightforward. We just need some DuPont wires for that as well. Just some, I think they're male to female that we need. So how do we address the pixels? So the very top left of the pixel display is the 1 by 1. And the way that we address it is we just say rows and columns. So in our code, we can either address individual pixels, or we can just load up, which is what we're going to do, an array of pixels which we've already defined as on or off, and then we're just going to say write that to the display. So really, really simple. The orientation I've got there is that the pins are on the left hand side as you look at it. So that's pretty much how we have these things wired up as well. So if I hold this up to the screen there, I think that's how we've got them wired, unless I've put that upside down. I actually have put it upside down. There we go. So just reverse that, there we go, and then just, there we go. Right, so that's now correct. That's now got the pins, if you can see that on that side to the left there. So that means that top left pixel there is 1 by 1. Okay, so very simplistic to do. So let's get creative with this. So draw a grid. When I was putting the animations together myself, let me just show you what I did in my little notebook. Let's see, there it is. I think I'll find it. I literally just drew out a couple of grids and started filling them in. There we go. It's never there when you want it, is it? There we go. Right. So I don't know if you can see that, but literally on my little book there, I just started drawing some grids, 8 by 8, and then filling them in with my pencil. That's all you need to do as well. So that little grid that we're creating there, that's actually called a bitmap. When we store bits of information like this for graphics, that's where the term bitmap comes from, because we're going to be switching bits on and off. And the way that we transfer this into our code is we need to tell the computer in 1s and 0s which LEDs are on. So 0 is off, 1 is on. And we just need to tell it in rows of 8 bits at a time. So that's what we're going to be doing. So the first step is if we want to draw some kind of face, and these aren't the faces that come with the module that Kev Thomas designed. These are my own design, but very similar. And yeah, so 0s are off, 1s are on. Each group of 8 bits is called a byte in computing. That's a very common term for talking about 8 bits. And you can also call that a word. You might often hear a word being described, which is just a collection of bits of a specific length. And there are all different lengths of word as well. So 4-bit words, 8-bit words, 6-bit, 12, 16, 32, 64, depending on what the actual use is. So in audio, they have a lot of, is it 12-bit, 10-bit encoding, 16-bit as well in there. 8's very common for this kind of low-level stuff. This is an 8-bit processor that's in the Arduino, so it's quite common that we're going to be dealing with bytes. So that's all we need to do, and you can see on the the little snippet of code I've got there. So just ignore the static const progmem. I'll get to that in a moment. We can see that we've got an array that's called smile. We know it's an array because it has these square brackets, and then inside we are giving it a block of bytes. So the B at the beginning means that the next thing that follows is going to be a byte, and we are actually giving it the individual zeros and ones, and they will correspond precisely to the face that we've just drawn. This is why it's such a good project to do, because it's computing, it's raw, it's kind of hardware level, but it's something that's real in the real world. So I love this. So you can see there, the circles of the eyes, the kind of squares really, aren't they? You can see them represented as well, just there. And you can see the little smile as well is just there. So that's working great. And the 4 lines of code that we need to bring this to life, very, very simply. So the first thing we need to do is clear the matrix. We don't know what state it's in. We consider that to be a dirty state. We don't know what it's in. So issuing a clear command will wipe the display of any garbage that's on there. And we have a nice all pixels off state. Then we're going to draw something. So we use the draw bitmap. The 0, 0 is the position that we're going to start in. So we say smile. 8 by 8 I think is where we finish. And then we're going to give this the LED on state. So it knows what to do with that. So the smile, we just go back a slide, is the name of the array that we're using there. So once we've defined one of these, and we can define many of these, we can very easily just say, just smile, just send this there. And then we just write the display. So drawing it just creates a buffer in memory in effect. And then writing it moves that buffer onto the actual display. Then the next thing we need to do, and this is quite an important step and one that's very easy to forget about, is to have some kind of delay. If we don't have a delay there, it'll write it to the display and then do the next command that's available. And that might be to write something else to the display. We might not even see it because it's flashed on so quickly. So we definitely need to have a delay. And that's not all. If we have a sequence of these faces, we can animate the face. So I did this with the sort of blinking effect. So I thought, how's this going to work? I need to have a face that's kind of normal, a face where the eyes are closed, and then I'm just going to use the face that's normal command. And the normal face, I just call that smile or neutral. I think neutral doesn't have this, the smile, it's just got a sort of flat line as a mouth. But the blinking with the smile and then not. And then in between that we have an initial delay of 1 second. So these are in milliseconds, I think. So we have 1,000 milliseconds in a second. Then we want to delay by basically 1/10 of a second, 100 milliseconds. Then show the face. And what this will do is it'll have the effect of going, blink twice. And you can play around with the delay to get it just the way that you want, but I think that works quite well. It looks quite natural and makes the robot look like he's actually, aware and listening to us. So I want to show you some cool things now. So I've got set up over here. Let me go over to the overhead display for a second. I've got this robot here set up, and he has got a Bluetooth thing. We're gonna do this next week. I'm going to show you how to get the Bluetooth working. So what I need to do, I've got an app that's called Dabble, and in Dabble I'm just going to find the Bluetooth device which corresponds to that robot there. I think it's called, is it DSD Tech? Let's try that. Okay, so it says it's now connected. So if I press that one there, it should smile. There we go, he's smiling. If I press it again, he's just going to go to neutral. If I press this one here, he's going to be sad. If I press this one, he's going to start crying. Now that crying is an animation. So there's a series of about 7 frames where I've had to individually move that pixel down, and I'll show you how we do that. He's also got this one that's like oof one. So you might have seen that. So, and then the bottom one there is in blinking. So that's the 100th of a second, sorry, 10th of a second between the delay, and it looks quite natural as he blinks. And the other thing that we can do as well as all those different animations, we can make the robot go backwards and forwards, left and right, and we can also make it play a tune. There's so many different tunes we can do with this as well. So another one that I've got just here, if I plug in his power for a second, it sounds a bit like R2-D2, a little bit, and that's just coming out the little buzzer that's on top. So some of these are some of the things we're going to be looking at over the next couple of weeks. How to do things like sound. We can make it play a tune. We can even sample a sound like a voice or a movie sound and play it back through the Arduino. Although it works, it's just quite crude. So we can do that. So let's get back to our animation. Let's get onto some code in a second. Before we do that, so if you're enjoying this video so far, and I hope you are, please remember to subscribe to the channel. It really helps me out, grow the channel, get it in front of more people. If you drop a comment on that as well, even in the live chat if you're watching now, or later on if you're watching a replay, just in the comment section below, just let me know what you think about this. If there's anything that you'd like to cover in one of the future episodes, please let me know. And I've got a ton of ideas. I've got an inexhaustible supply of ideas for SMARS. We haven't looked at power yet. That's something that people talk about a lot. Motor shields is something that comes up time and time again. So there's quite a few topics that I want to jump into, as well as just want to expand you know, our use and our knowledge of SMARS. So helping subscribe to the channel, liking this video or not. If you don't like it, give it a thumbs down. Again, these are signals that help me understand what works and what isn't working. And the other point, I get the analytics in the background. I can go into YouTube Studio and I can see just how many people have watched this, usually the people on replay, and how many of those people haven't actually subscribed to the channel. So if you're enjoying this and you've watched this far, why not subscribe? You know, you'll get a bit more out of it. And the other thing, if you want to get a copy of this presentation that I'm using right now, just visit action.smarsfan.com/fun. And that will help you sign up to the mailing list that I'm trying to create of all people who are interested in this kind of thing. So I can send you out news, bonus guides, special offers, all that kind of good stuff. And yeah, you'll get more guides. You'll get all that information that's in here. And at the very end, I've got some bonus faces and animations and stuff as well. So that'll all be included in this pack if you download it. So if you want that, head over to action.smarsfan.com/fun and just sign up there. And it's free. Cool. So let's do some code. Let's crack over to, that's the right one, yep, to the Arduino, and let's actually figure out how to bring this to life. So let me just see. There we go, that looks much better, doesn't it? Right, so I've actually written this program out already. I think it might be better if we start from scratch and just refer back to this one if we need to. So I'm going to create a new file, and I'm just going to call this one, and I think I might just need to switch over as well on eCam, just so we can see. So Arduino sketch, there we go. Right, so yeah, that works well. So what we need to do first is we need to include a couple of libraries. So the way that we do that, we do #include, and then we type the name of the library that we want to include. So these are all related to how it connects to the matrix, LED matrix. So the most important one is Adafruit. Their libraries. They've done all the hard work for us. I need to spell that correctly, of course. GFX for graphics. And then the last one that we need to include is the main one, which is the Adafruit. Fruit LED backpack. There we go. Just need to make sure that I've typed that correctly. So I've already loaded in the LED backpack library, as we mentioned earlier on in the slide deck, where we install the library. So that's already installed on my machine. That should be fine. The next thing we need to do is we need to initialize it, bring it in as a variable. So Adafruit 8x8 matrix is the name of the type. We're just going to call this matrix, and we're going to make it an Adafruit 8x8 matrix. Okay. Now, this is where it gets quite interesting. So what we need to do is we need to store these faces and animations in memory, and we need to use the program memory of the Arduino to do this. So we're going to say static, because it's never going to change within our code. It's a constant. It's an unsigned integer. I'll explain what that means if you don't know already. And it's called progmem. So an unsigned integer, an integer is just a whole number, 1, 2, 3, 4, 5, 6, that kind of thing. Unsigned means it doesn't go minus, so we don't have minus 1, 2, 3, we just go from 0 upwards. And if we're using a byte, which is what an integer, an 8-bit integer is, then we can store up to 255 different values, or 256 if we include 0. So that gives us our range of numbers that we can have there. Given that we're only talking about storing a byte of information and it's on or off, we don't need to store anything more than 255 different values. So what we then need to do is we need to define some graphics, some faces. So the first one we're going to do is our smile. So let's define smile. It's an array, so we need the square brackets, and then we need to open our curly braces to say what it is. The first one, so I'm going to refer back to that slide deck. Let me just show you again. Let's go to that one there. So if I'm going to draw this smile, the first row is going to be all zeros, and then it's going to be 1, 1, 1, 0, 0, 1, 1, 1. So 3 ones, 2 zeros, and so on. You'll get the feel for this in a second. Let me just show you on the screen. There we go. So you can see there, that's what we're going to be drawing. The first line is all zeros, 1, 1, 1, 0, 0, 1, 1, 1. So it's much easier to do as you're typing it out because you can see it. You can actually see it in the, oops. Let's get back to my code as we type it out. So the first line is 1, 2, 3, 4, 1, 2, 3, 4. And then we have a comma. Let me just make sure, there we go. And then we do the next line. So the next one was 3 ones, 2 zeros, 3 ones. Then it was kind of like that for the eyes, the middle of the eyes, then the underneath the eyes, and then the next line is all zeros again, I think, and then oops, that needs to be capital B. Then we need just one, I think, in the corner, is it? Yep, like so. And then the next one is that's like so, and then I think the bottom line is all zeros. So for now that should be it. I think we just need to have a semicolon at the end of that to say that that's the end of our array. So that's our smile. So next what we need to do in our setup, we need to initialize the matrix. So we say matrix.begin, and we need to pass it the address. I think these are all the same. I think it's all 0, like 0x70, which is the hexadecimal address of the display. I've not come across any that don't work with that, so let's just go with that. That works fine. So next what we're going to do, we're going to create a little function called smile, or face smile. So void face smile, and let's just put some curly braces there. So the first thing, if you remember, was we need to clear the display. We need to make sure that anything that was on the display is wiped off. Then we need to do the draw bitmap. So draw, and then it's uppercase, bitmap. So we start at 0, 0. We want it to be the smile array that we've just created, and then we want to end at 8 by 8, and we want LED on, like so. And then we want to write that to the display. So write display, like so. And then in our main loop, all we want to do there is just say face smile, and we'll give it a delay of 500, so half a second. But because this is a loop, it'll basically just smile and stay on. That's what we'll see. So what I will do, I'm just going to reset that face that's currently on it, just so that we can see that it's actually working right. So if I go over to the overhead display there, you can see it's got this neutral display on. This is just the, whatever was on the display previously. But we're going to wipe everything that's on this Arduino. I've got the cable wired up. It's just it's actually plugged into the back of this one. Just see there the cable, and that's plugged into my laptop in front of me, just in front of me here. So what we're going to do now is we're going to upload that program. So let's go back over to here, and let's press the upload button. I'm assuming that my code is perfect and that I don't need to test anything out there. It's just asking me to save it, so I'm going to call this smile, and let me just show you what's going on there. There's just a little dialog box open, so I'm just going to save this in fun with SMARS faces, and I'll call this smile. There we go. Right, so there was a problem. It said, oh, what's happened there is I've missed off a little semicolon just there, so that's what that was complaining about. Other than that, I think it's happy with it. Yep, perfect. Just one mistake. That's not bad, is it, for live coding? Okay, so it's uploading the code. If we now go over to, if you remember, the face was neutral, it wasn't smiling at all. If we go to the overhead now, it's now got a smile on its face. So that's the code running, that's the code working. So we want to try and do one last thing. We've got enough time to do this today, so we want to make it do the blink animation. So we need two faces for that. We need one where it's got the eyes open, which is our smile one. We need another one where it's got the eyes shut. We can call that blink. And that's all we need for that animation, just those two frames, and we can just switch between them with our code. So let's get back over to our code. So what we'll need to do is go back up to our little smile array there. So instead of it having the end there, I think what we do is we just do a comma. We then create a new array, so we're going to call this one blink. And is it going to be happy with that? Maybe we should call it face blink or eye blink. Yeah, just blink's a reserved word, we can't use that. So that's fine, and then equals some more curly braces. And this time we're going to do very similar to what we've got there. In fact, we could actually copy that entire array and just change the bits that we need. So if I just do copy and paste there. So where we've got the eyes here, I'm just going to make them shut. Again, this is much easier to do if you've drawn it out on a piece of paper, because then you know exactly what you're typing in. But I can actually visualize this, so this is fine. I've done this before. Right, so that's all we need to do. We're keeping our smile. The eyes are now look like they're shut. They're just two lines. So that's eye blink. And then we're going to do a new function that we're going to call face blink. Or face blink. Let's do that. And what we will do in there is we will borrow that piece of code there. We could actually, instead of borrowing it, just call it. So we could just say face smile. It's much more efficient, isn't it, to do that? Then we want to delay for initially 1 second. So that's 1,000 milliseconds. Then what we want to do is the face blink. So what I'm going to do there is I'm going to copy all that. What am I doing here? I'm going to copy all that there. I'm going to paste this underneath, and we are going to put in there the eye blink, like so. We're going to write the display, then we're going to delay for 100th, so 1/10 of a second. So just take off one of them zeros. Then we're going to do the face smile again. Essentially, we're going to repeat this entire block. We could make this code so much more efficient by just some better programming techniques, because we're basically just doing the same block of code twice. We could write function and just call the function twice. But for speed here, we're just going to do it this way. So what's going to happen there is it's going to smile. It's then going to do the blink for 100th of a second. Then it's going to smile. And what we want to change there is another 100th of a second rather than 1 second. And then it's going to put the eyes shut again, so that at the very end we just need to have the face smile as the last one, just so that it returns to what it was previously. There we go. Okay, so if we come down here now, instead of having the face smile, if we change this to is it face blink? Yes, face blink. And let's run this, let's upload it and then run it, and let's see what happens. So the code looks fine. I'm just going to switch over to, there we go. So you can see now on there he's doing his blink, he's waiting a second and a half probably, and then he's doing his little blink. So that's how we animate it. So if you want to do something more complicated, like the crying one, you would have to create that block of code that's got each of the different faces in. You would have to create a frame for each of the states that it's going to go through. So, you know, one where there's no pixel for the cry, you know, for the teardrop, and then it's going to move down the face one frame at a time. So it's a bit tedious to draw that out, but that's essentially what that's all about there. So I can show you how that looks if I just go over to previous one I've created, which is called Dabble Test. But let me just load this up. Go over to the code. Let me switch over to the correct program, which is that one there. So you can see on here, if I just resize this so we can have a better look at the screen, a bit more zoomed in. Right, we can see on here we have smile, we have wink, which is just one eye like that. We have the neutral face where it doesn't have the little ends of the smile. I've got a frown where he's not happy. We have a joy one where he's like this. We have a smile blink, which we just created. We have one that's called shock where it's like one eye open, one eye closed, and a mouth open. And then this is the bit I wanted to show you for the crying animation. So we can see on there, it starts out with it's kind of got, I was trying to draw eyebrows where it looks like that. The eyes are open with a mouth, and then the eyes shut, and then the teardrop goes down one frame at a time. So you can see this one that's here. That's our teardrop. That's moving down. We're on cry frame 4 there, cry frame 5, cry frame 6, and then finally cry frame 7 where it's just like that. And then you can see there, I haven't made my code particularly efficient there. So the blinking one is exactly what we've just created. The neutral one just draws the neutral one. The winking one just draws the winking one. The shock draws the shock one. The cry, you can see there, it goes frame 1, frame 2, frame 3, frame 4, frame 5, all with a tenth of a second between each of them. So these are quite trivial to actually put together. The bit that's hard is sort of figuring out the actual frames themselves and drawing them out. What I've done on this one, I've created a little, let me show you what happens on here. You can see there's other tabs as well. We'll get to this in next week's stuff. So if I just upload this one, just so that it's loaded up, I will then, actually, do we need to, that's fine, it's working. So if I go over to the overhead now, I'll load up on my phone the Dabble. I think, do I need to do anything there? No, I don't. Right. So what's happening here, when I press these various different buttons on the display, you can see that when I press these various different, so there's like square button, round button, triangle button, cross button, start and select, and then we have the different movement buttons. Each of them is just a button that you can detect has it been pressed. And if it's been pressed, you can then call a function such as the blink, the cry, and so on. And I've also loaded into this particular piece of code all the movement code that we created months and months ago for making the robot move backwards and forwards and turn left and turn right. So that's all in there as well. And I've also loaded in there the little tune. I don't know why I picked this one. I was thinking of Dukes of Hazzard, but I don't know whether that's really appropriate in this day and age or whatever. So, and there we go, there's the crying animation as well. So you just press it and it'll just do one cycle of it, but we could have this sort of going over and over if we wanted. And there's the frown, and there's the neutral, and there's the happy, and then there's the blink. So I'm just pressing that there, and we can just see what's happening. Press that one, that's neutral. That one is smile, neutral, frown, cry, and then backwards, forwards, left and right. Now I'm using an iPhone, and the Bluetooth module that we got in there has to be a specific type of Bluetooth module that works with iPhones. If you have an Android phone, this isn't a problem at all. Any Bluetooth module will work. And let me just show you just how many Bluetooth modules I tested out on here. They're not Bluetooth modules. So I've got lots of different types here. Basically every different range of Bluetooth module you can imagine, I've got them, and probably a few different types of each. So that I think is HC09, and the other one is a HC10, I think. So these both work with iOS, and it's to do with licensing, Bluetooth licensing, I believe. The other ones are HC05 and 6s, and they do work if you have an Android phone, just as well as everything else. The difference, the reason that they changed the licensing, it was to do with power consumption. So the 9 and 10 and 8, 9 and 10 are very power efficient. They use Bluetooth 4.1, 4.2. The older modules, the HC05s, I believe, use a much older version of Bluetooth, and that's a lot more power hungry. So with the iPhone, they wanted to make sure it didn't drain your battery. So that's why that little thing exists. Just thought I'd let you know about that. So I hope you have enjoyed the coding part of this. There is just so much we can do with this to make it more fun. So we could we could make different scenarios have different expressions. That's kind of what I'm thinking there. So the other thing I did as well, let me just show you that. If I go over to the serial monitor, I created a little test program. Let me just find it and then I'll share my screen with you. Let's see, I think it was called Face Interface. There we go. Right, so if I go back to share my full screen there, and I just need to swap over which one we can see. So it's the Face Interface. That one there. Right, so what I did on this piece of code, when I was trying this out, I've got all my different faces there. I created a little menu at the very bottom. So it reads in from the serial monitor what key you're pressing on your keyboard, and depending on what key you press, it will do the different face. And that was before I got onto doing it with the remote via Bluetooth. So this is just via serial. So if I load this one up, I'm just going to hit the upload button there. It's just compiling the sketch. And we can just see on our overhead there, once that's uploaded, let's wait for it to, there we go. So he's just got his regular face there. And if I go over to my keyboard, so what I'm going to do now, I'm going to open up the serial monitor. So let me just do that. Let me share my full screen. You can see there it says SMARS Face Interface. So if I press F for frown, and I press that, what's going to happen is it's going to frown. If I press C for cry, it should do a cry. Let's see if that's working. I think I might just need to give it a reset for that to work, because I think it was still connected to, there we go. What am I doing wrong there? So that's uploaded. So S for smile. Let's try S for smile on there. F for frown. So that, for some reason that code doesn't seem to work in this exact moment in time, but you can see there the idea. I've got a loop running. It's going to read from the keyboard, from the serial monitor, and depending on what we press as a key, it will then actually display that face on the SMARS robot. And that was just a way of building out all the different animations and testing them out quite interactively. So one of the little videos I did, it's a YouTube short one that's called How to Make a Robot Cry. How to Make a Robot Blush, sorry. You can see me sort of like tickling it, and what I'm actually doing on off screen is just running this program and pressing like the frown, the cry key, the smile key, and so on, the shock key and the joy key. I'm pressing all them on my keyboard, but just filming the face of the robot. Whereas the other video I did as a sort of teaser for this one, where you can sort of see it drive into shot and then drive off, that one is entirely done through the Dabble app and the Dabble library. And we'll look at that next week on how to make some sort of Bluetooth racing robots. So we'll extend our code and we'll also have sort of racing robots. So I've got quite a few of these on the go. There's at least 3 of them there. We can, if I get 3 people with Bluetooth phones in the same room, we can all race them together. So tons of fun. And the motors aren't all geared exactly the same. They should be the same, but I often find that they're not. So racing them could be a could be a genuine race. So tons of fun there. Okay, so let me just go back to the keynotes for a second. Let me just bring up Keynote. Let's see what else we could also. We talked about that. We talked about that. We've done some coding. So comment of the week. Yes, let me bring up comment of the week. So Jack Williams commented. And he said, great design, great video. So I can't take any credit for the design. This is all Kevin Thomas's design. I just sort of make this popular, and I'm his biggest fan, I would say, hence smarsfan.com. He says, I'm going nuts, however, because I've ordered the... And it just goes off because my head's in the way there. He's ordered some components, found the site the other day, can't find anything at the moment. So he's talking about a bill of materials, the bomb, the servos, how to use that, what does he plug the batteries into. So I think batteries and power is something that we should look at in one of these videos, because it comes up time and time again. In fact, when I was actually doing some prep for this live stream today, I had this robot here plugged in, and again one of the issues is, as you can see, he's got some power there, but not enough to actually drive him forward. So I quickly got another battery out and just plugged that in just to give him some extra juice there. So you can see he's a bit brighter when he's running on that battery. There we go. But getting the batteries in and out of these is a real pain, because it's not really designed for you to be able to get them in and out very easily. They sort of, once you put that motor hold cover on the top, it kind of locks the battery into place, and it's quite tricky then to replace the battery. So unless you've got a rechargeable battery, or you don't use the 9-volt batteries at all, so other options that we have are like lithium polymer batteries, the sort of flat ones that you get. You can have the 18650s, which are the ones you find in sort of e-cigarettes and vapes. I think they've made them quite popular. But there are also the batteries that are in Teslas, in the sort of older Teslas. In my Renault Zoe electric car, they're all 18650s in a big pack. So very popular batteries, and you can get some that are very powerful, last a long time as well. So they're a really good choice, but they don't fit very well inside the SMARS as it is. So if you have... Here's one I prepared earlier. This is the version 4 of the SMARS. So this is a sort of paid-for-play version. It's got the nicer wheels that have... make these come out. They never come out when I want them to, but then... There we go. So they've got a really nice sort of design to them. If I can just show you that there. Really sort of smooth, and they just push into play there. And the idea is that you've actually got 4 motors inside, and that's the motor shield. Look how small that is. So I'll be doing a video on this when I get round to it, and the idea is you've got then all that space there that you would normally have where the 9-volt battery is in the motor shield. You don't need that. You can put some 18650 batteries in there. They do fit quite neatly. So there is a holder module that I've got just off camera there. So I'll be working on that and seeing how that goes. But I think we need to do an entire video on power and all the different options we've got. People have built all kinds of add-ons, modules, holders. Some of them hold the batteries sort of over the wheels in sort of that kind of configuration. Some people have them on the back. So, I mean, the good thing about the 9-volt battery is it's perfectly placed between the 2 motors weight-wise. So the weight's really low down, and it's equally balanced between the 2 motors. So the centre of gravity is really good. Putting the batteries higher up or to the sides can make it a bit more wobbly. So that's something to consider. But I think putting them in the middle, that will work fine as well, because it's, again, quite low down compared. So that's something we'll cover in a different video, I think. But back to the comment of the week. Let's make sure it's not blasting that sound out. So yeah, back to that comment of the week. So he was just wondering how about that. He said, I'm not yelling, I'm just going nuts about how we can get everything together. And he wanted to make sure there wasn't anything else that was needed after he'd ordered everything. So he was also talking about an on-off switch. Again, one of the features of the SMARS version 4. I believe there is a space there for an on-off switch, because that was sort of sadly missing from that. So the new version, but again, that's a paid upgrade. It's not very expensive. It's about $4, something like that. And you know, Kevin Thomas has given all this stuff away for free. So having a paid version of you know, a slightly more improved version, I think is fine, isn't it? I think we should all support him in the work that he's done. Given the fact that he's just given this away for free to the world. So that's the comment of the week. Let me just go back to my slides and we can have a see what else we've got there. So yeah, we have a new video every single Sunday at 7 PM without fail. So it's relentless. I have to keep coming up with new content every week, but like I said, there is an unlimited supply. So I'll be creating these for a long time to come. I've tried to include all the popular time zones because I'm in the UK, so I'm Greenwich Mean Time, the ground zero for where time starts. I'm about 200 miles north of where Greenwich is, to be honest, but I am within that time zone. So the left-hand side of that column, you can see there's quite a few this sort of Americas, North American type stuff. We have in the middle Europe, and I think we have India, Pakistan, and some Russian time zones. And then on the right we have very far east, we've got China and some Australia as well. So tried to cover all the time zones, so apologies if yours is not on there, but I think you know roughly which one you would be part of there, just so you get an idea for when we're going live, because it's great if people can actually join live. I can see we've got 4 people currently watching live, and it's great to get a bit of interactivity there. So I can see Lementis Reductor's on, we've got Willis 3D Druck on there as well. So hi, how you doing? I can just press that and you get a shout out there as well. So every Sunday we have a video. So the other thing I want to give a bit of a call to action on is if you've not already looked at the SMARS fan website, so that's a website I put together to try and bring together all the information about SMARS robots. So that's both the quad version and the wheeled version, and all the modules and add-ons. I've tried to bring that all together. I've also put an index of all these videos. If I create some lessons and tutorials, I often do a write-up. So I've done a write-up for this one as well. You can get access to that as well. As you can see on the screen there, all the different code, and I explain line by line, tediously line by line, what each piece of code means. So if you work in education, you work with kids, or if you just want to educate yourself on how to build these things, it's all there. So my plan for 2021 is to build this out massively so that we've got more stuff on there. I also have a little online store there, and I've not had many orders through this online store. I want to do a better job of that, because some of the timescales when people have ordered things have not really been very satisfactory. I've had some feedback about that. So what I've done yesterday was order a stock of 20 kits worth of SMARS stuff. So one of the projects we're doing over the next couple of weeks is building that into a kit that you can purchase that has all the different components in, if you haven't got them already, with some instructions in a nice little kit form, competitively priced as well, so it'll be just as cheap, if not cheaper, than what you can buy via Amazon. But I'll be shipping them from the UK, so there'll be no waiting 2 weeks, 60 weeks, whatever it is, from China to go to wherever it's going to. I'll be in control of that shipping, and I can offer you as quick delivery as you want to pay for. So that's something I'm looking at doing over the next couple of weeks. I'm just waiting for the parts to arrive myself, so I shall then have an inexhaustible supply of SMARS robots. If people don't buy them, I'll just buy them. I'll just build more robots. So it's a win-win for me, really, I think. So that's that. Let's back up to the slides. Was there anything else we needed to say there? So yes, next week. So we're going to be looking at racing SMARS. How do we make these things be able to race each other? So we're going to be doing that with Bluetooth. I'm going to be showing you how to use this Dabble app. I've got an Android phone and an iOS phone, so I'm going to try and get it to work on both of them, so we can see that it does work. And yeah, the library there is called Dabble. So if you haven't got Dabble, get that downloaded onto your phone. It's a really good library. You can extend it and make your own Bluetooth creations with it. It's very, very easy to code. We're going to be looking at that next week. We have used it in the past. I have covered this in a Bluetooth episode. If I remember, I will put a link up in the cards for anybody watching on replay. But yes, that is something that we're going to be covering off. It is so much fun. We're going to be looking as well the week after at music and how to make sounds through our Arduino. I need to just check on the sort of copyright license of doing little snippets, because there's an R2D2 sound effect that I really want to share with you, but I don't want to get a copyright strike at the same time. But again, it's one of them things that you think, it sounds like it'd be really complicated to do, but when you get into it, it really, really isn't. So we can take a sound clip of anything. It could be you just sort of saying, hey, you can then sample that. You export it as a raw sample at a really low bit rate, about 8 bits, I think it is. And you end up with, just like we've done with the ones and zeros, you end up with a load of hex code that you just copy and paste into your program memory of your Arduino, and then you just play that back through the speaker. And if you've got one of the Arduino shields that has the little speaker built in, such as this one here, or you can buy, I think I've got a whole box of them just up there, the little speaker modules. We can wire one of them up as well and just try that out. Very, very simple to do. I think they're just a piezo buzzer. We can play back the sound, so we can do so many things with this. This is just so cool. There's so many different directions we can go with SMARS. I just can't not get excited about it, to be honest. So there are a couple of things I'm going to be looking at. So this entire series is all about having fun with SMARS. So if you haven't joined the SMARS community on Facebook, search that out. There is a ton of people on there. A lot of people who've already built them. There are a lot of people who are just starting out. I'm there. Kevin Thomas is there, the creator of it. You can talk to him as well. So if you're not on the SMARS community, you absolutely have to join if you're watching this. Check out my website as well and give me feedback. There's a little messenger bubble at the bottom of the screen on a lot of the pages. That comes to me directly. You can ask me, or say, where's this piece of information, and I can make sure we put that on there. So it's a site that I keep up to date, and I know I can put more information on there all the time very quickly. So there's that. If you're not subscribed to the channel, definitely make sure you subscribe. If you've watched this far, you absolutely should subscribe to the channel. What are you doing if you've not? So let me know what else you think we should cover in these videos as well. So you can do that in the live chat, or you can do that in the comments. You can do that via SMARS fan, via the little bubble. Bez, how do we pronounce that? Rengifo, is it? Sorry if I just mangled your name there, Bez. He says, awesome stream. Thank you for that. I really appreciate the feedback. And this has been a really fun one to do, to be honest. So if you want to get a copy of this slide deck with all the little animations and stuff and all the info, just go to action.smarsfan.com/fun. You can grab a copy of that there. You just have to sign up to the mailing list. And what you can see there, I'll give you a really quick sneak peek of this. There's some extra faces there. So if you're watching this on playback, you'd have to go back and pause it exactly at the screen, or you can just go to the website and grab a copy of all this stuff, because it's in this slide deck. So there's loads of extra stuff on there, and I'll be mailing you, just telling you, what's going on really. So thank you so much for watching. This has been a really great stream today. I can see we've had more people than quite some time, so thank you very much for your sort of coming along. And this is the last one we do before Christmas, so the next time I speak to you will be after Christmas. So make sure you have a really good Christmas break. If you're having any other festivals, enjoy those too, and I shall see you next Sunday. So thanks everybody. I shall be seeing you very soon. Thanks for watching. See you next time.